Assalamu alaikum. Welcome to our project OS algorithm and problems. We have the OS algorithm and problems project. So we have the three different categories in our project. The first one is process scheduling algorithm. The second one is disk scheduling algorithm, and the third one is process synchronization problem. So in the first process, we have 9 different processes. For example, first come, first serve, shortest time, first shortest remaining time, first round robin, and so on. So we have 9 different algorithm in one program, which are written and given a choice for user. If, for example, from 1 to 9, if the user press 1, it will show, for example, first come and first serve, and so on. And we have in the second second disk scheduling algorithm, we have 6 different algorithms. For example, first come, first serve, lock, c lock, um, c scan. And in process, in the third category, we have the process scheduling problems, where we have 3 different solutions for 3 different problems. And the first one is dining philosopher, from which you are much familiar, and the second one is producer consumer problem, and the third one is reader writer problems. So let's take a look uh, in performing it physically. uh, so this is our project OS, which is on the desktop. We go to the project. So the first I select the process scheduling algorithm. I open it in the terminal. For example, I left click it and run the terminal. I am maximizing it. So first we will compile the program. For example, we have the problems in written in C language, so we can compile it with the GCC minus O obj. I'm giving the name to the compiled file obj, and we have for example, uh, the process scheduling algorithm. uh, what's the name of the program? Is the process scheduling algorithm. So I enter this, and it compiled successfully. So I tried to learn to run it with the command ob dot slash obj. Here we have 9 different choices. As I told you, the program will give 9 different choices to the user. If the user press 1, for example, it will take the user there to the first algorithm, first come first serve. And if the user press 2, it will take the user to shortest job first. And if you press 3, it will let the user to run the shortest remaining time per algorithm, and so on. And in the last, I have given one more choice, that is 0. If the user is not interested to go to any algorithm above, so he can press 0 to get rid of the program. So for example, I press 2, which is for the shortest job first. So I am entering it. Here we got a message, total number of processes. So for example, I have 4 processes, and now it's asking for the arrival times for the 4 processes. Usually the process come in ascending order. For example, I give the process 1 arrived first, and then the process 2 arrived second, and the process 3 arrived third, and the process 4 arrived fourth. So now it is asking for the burst times. So for example, the first program, first process P1 takes 3 unit times for as a burst time, and the process 2 takes 4th burst time units, and process 5 takes 5 units as a burst time, and the process 4 takes 6 unit as a burst time. So here we got a process table where we have a PID, 7 different columns. The first one is PID, where the mention or where we have mentioned the processes P1, P2, P3, 3 and P4, and after that we have our arrival time that I have given, and also the BT, BT burst time. Here is the burst time which I have already given here. So it calculated the completion time, the completion time for the process, when how much units it has taken. I mean process 1, process 2, process 3 and process 4 has taken for completion, and then we have total turn around time, TAT, total around time. So the process 1 has completed taken 3 units for turn around time, and so on. Process 2 has taken 6 units, and the process 3 has taken and 10 unit of time turn around time, and process 4 has taken 15 turn around time units. So here the last one is WT waiting time. The process 1 has waited 0 unit, the process 2 has waited 2 unit times, and the process 3 has waited 5 unit time, and the process 4 has waited 9 unit time. Here the program calculated the average turn around time, which is 8.50000, and average time as calculated and shown, which is 4.000, and so on. Now we can say another their algorithm by running the program again. So for example, I take 3 or 4, anyone you can take from the following choices. So I take the third one, a shortest remaining time first. So I enter the third one, and it's asking for the total number of processes. For example, I give the 3 number of I have 3 processes, and it is also asking for the arrival time of the processes. For example, first one came first, second one came second, and third one came third. So for example, I give the first time for first one take 4, and the second one for example 7, and the fourth one for example 11 unit time it has taken as a burst time. So here we have the same process table which I explained earlier. So this is a table. So it calculated the average turnaround time, which is 11.333 and average waiting time is 4.000, and average response time, which is 4.000. So it was the program shortest remaining time first. So it took the shortest processes first. So we can check another algorithm by selecting any choice. For example, I take the ninth one. For example, highest response ratio next. So I press the 9, and it's asking for the processes as for the previous one. So I give the 5 processes. For example, arrival time, it's asking arrival time. For example, first one came first, second one came second, and third one came third, fourth one came fourth, and fifth one came on the 5th position. So it takes the it's asking for the burst time. For example, I give the first I give 2 units to the first process, and then I for the the second process I give 9 units, and for the third process I give 5 units, and for the fourth process I give 1 unit, and for the fifth process I give, for example, 8 unit of time. So here it's again a process table mm, for highest response ratio time. So I have explained it briefly in the first algorithm. So here it calculated the average turnaround time, which is 11.400 units, and the average waiting time is calculated and shown, which is 6.4000. So for example, I cancel this algorithm, and we move to the next category, which is for example, I go to the process synchronization problem. Here I open terminal in this folder or directory. So first I will run any one of the following problems. So I compile it with the GCC -o obj. I'm giving the name to the compiled file obj, and then for example, process consumer problem. I take the process consumer problem first. So here it compiled, and I will run it with a dot slash obj. So it run successfully. So we have three options. The first one is for consumer, and the second one is for the first one is for producer, the second option is for consumer, and the third option is for exit. It is a simple problem where where we have a buffered solution. The first one, for example, the producer will produce any job or anything, and then the consumer will consume it by pressing the option 2. So we will check it practically. So first I check if I want to consume. I have nothing in the buffer, but I want to consume it with option 2. So it said to me the buffer is empty. So first I have to produce any job by the choice 1 producer, and then I have to consume it. So I give the first choice. I will produce any job or any food or anything. So it produced item 1. So I again press 1 to produce another item, and again I produce another item by giving the choice 1. So I have produced 3 items. Now I want to consume all the 3 items by selecting the choice 2, which is consumer. So I press 2, and it consumed 1, and then I again. So we have 2 items remaining. So I give the 2 to consume 1 more, and I give 2 to consume 1 more, and now if I give the choice 2, it should show me that the buffer is empty. So here we got, and the buffer is empty. So this was all the producer consumer problem. Now we go to the third category, which is disk scheduling algorithm. So I open program in the terminal here. First I will compile any one of the algorithms by the command gcc -o obj obj you can give any name to it. For example, I give it fun, and I have look dot c program. So here we got a warning which is not, for which we have not to worry, and if we go and go with the dot slash Irfan command to run the program, and here it ran successfully. It runs successfully. So for look disk scheduling, enter number of the tracks in the disk. For example, I have 3 tracks. Visiting track, for example, I have 3, and entering the request queue, I have 4 queues, and 3 queues, and for example 2 queues. So it's asking for enter the current position. For example, I am on the second position. So choose a direction. It is asking for a direction, whether you want to go to right or left. So I want to move it to the right. So here we were on the we have total track movements 0, because we were on the right already. So that's enough. It's a track movement, and total track movements we have 2. So it's enough. Other problems are also implemented using highly optimized solutions, like this one and the previous one. So thank you so much. Here it is our project, and thank you, sir.